Today we're going to look at surds, the more common of the irrational numbers. So a surd, as we talked about yesterday, is an irrational number. Basically, anything that includes a radical symbol. We, of course, mainly look at square roots. So some rules, some laws. So the first one, which allows us to do the simplification of surds. So we're looking for a factor which is a perfect square. And division, usually it's easier just to look at the numerator and the denominator individually. And of course, inverses cancel each other out. So if we have the square root of something squared, we just end up with a. Okay, let's have a look at some quick examples. So root 50, perfect square, 25. Now we don't obviously write that line down, but our thought process is, okay, root 25 times root 2, but we know what root 25 is, so 5 root 2. We talked about this the other day, but technically the square root of x cubed can be simplified. Because we could write it as the square root of x squared times the square root of x. Square root of x squared is just x, and we get x root x. But remember what I said when it comes to algebra. Look at the actual indice itself. If it's an improper fraction, then it can be simplified. In this case, we would have had x to the power of 3 on 2, which is an improper fraction. Root 5 on 4, too hard to do, but if we treat each bit individually, we can find the square root of 4, so we get root 5 on 2. Root 20 on 9, in this case, both the top and the bottom can be changed. The bottom one can be worked out, of course. 3, the top becomes 2 root 5. Okay, surd arithmetic. Like surds can be added or subtracted, unlike surds cannot. Now that's very similar to something else I wrote down last week. And that was when we were just talking about algebra. We said like terms. And that's because surds and algebra are identical, because we're dealing with unknowns. The pronumeral represents an unknown. A surd is an unknown. We don't know what it is. So all those rules for algebra are pretty much the same as the rule for surds when we're manipulating them. So, like surds can be added and subtracted. I don't know what the square root of 3 is, but I do know that if I've got 4 of them and take away one of them, I've got 3 of whatever they are. And similarly, with the 2, if I've got 6 of them and 2 of them, I must have 8 all up. Exactly the same as algebra. Binomials, again, first outside, inside, last. And in this case, nothing tidies up. Difference of 2 squares. Ooh. Conjugate surds. These become very important later on in one of the things we end up doing. Don't want to spoil the surprise right now. So we had 2 minus 1. Just be real careful. It's so easy to go 4 minus 1 there and make a silly mistake because you go, 2 2's a 4. Perfect square. 2 squared is 4, twice the product, 4 root 2, and root 2 squared is 2. 6 minus 4 root 2. So all those same sorts of questions that we did with algebra, we see with surds as well. Okay, there's the first bit.